Mm-hmm. Yep. Did everyone hear me okay?
Yeah, check.
Cool.
Hey, everyone.
Welcome, everyone. My name is Jacob Zabel,
I'm Eric Henko.
and this is developing the Essential Mac Os Cookbook at Microsoft, of all places. So first off, a little bit of background on the Mac OS Cookbook. It's developed by our team of Apple infrastructure engineers at Office. We depend on this cookbook directly for many of our own management use cases. So maintaining it and updating it is a core part of our daily jobs. This means things like submitted issues to GitHub get brought up daily at our own stand-ups. And it's not just a side project for us. We generally ship an update to the cookbook once a week, so it's under continuous development. And we love open source. So the code is available at Microsoft's GitHub organization, where you can also find other cool projects like VS Code and .NET. And we love continuous integration. So any pull requests that you submit to our cookbook will actually be automatically built on Office Macs back in Redmond using Visual Studio Team Services. So if you want to find out whether our code, your changes will break our code or not, just submit a pull request and find out. Most importantly, it's available for everyone to consume and follow on the Chef supermarket. So just add Depends Mac OS and start using it right away. So why Chef-Repo for Mac OS at Microsoft? I'm going to dive a little bit into the history of Mac OS at Microsoft for just a minute or two. Microsoft has been shipping Office on the Mac for longer than they've actually been shipping it on Windows. So as you can imagine, there are a ton of iterations of managing Mac OS at the Office product group. We primarily support build and test for Word, Excel, and PowerPoint, but that's growing to other customers like OneDrive and OneNote. So the managing system images and distributing them with Apple Software Restore has been the established way of state management for some time now. And some of you are probably pretty familiar with this golden image system if you manage Macs. And it works okay until you need new images for every security update or dependency update that your developers need. And it especially starts to lose its luster if you go through a season of WWDC and Apple releases a new beta every single week and you have to put that image into production. So we started to look around for tools that could automate the provisioning of a macOS image, especially a VM, because I was personally tired of having an extra Mac Mini sitting in my office that I would just build images on. So the tool that enabled us to kick off automated image creation was part of the Chef TK. It was Kitchen CI. And Kitchen was really cool because it enabled us to instantiate a macOS instance without dealing with our hypervisor directly. And then we could use Chef code to provision it, and then Vagrant to package it up and convert it into something that our macOS nodes could consume.
Thanks, Jacob. So what you're looking at here is a set of instructions to create these monolithic images. If it looks overwhelming, that's because it is. This was state management before Chef. It's littered with mistakes and things that are outdated, like comments, and they lie, and there's, it's really, really overwhelming, and it's really hard to maintain. I mean, anyone who has used monolithic imaging, you're lucky if you have something like this. A lot of people don't even have this. It's just you get iterations and iterations of images being created. But I want to focus on one step in particular, which is disabling Spotlight. This is step 14, in the middle of like 6 pages. Disabling Spotlight, pretty straightforward. Go to the Apple menu, System Preferences, Spotlight, Privacy tab, hit plus, Command-Shift-C, go to the root volume, Mac.hd, you get it. In this case, we're disabling Spotlight because we want to save energy from building that metadata store over and over again. That's a lot when you're testing and building Mac OS, and so we want to save that as much CPU power as we can. So our question was, and challenge was, how to turn these English instructions into code. So I know there's a couple of Mac admins here. You're probably familiar with the mdutil command. In this case, it stands for metadata utility, and it's how you can manipulate Spotlight using the command line. So here we've added the off state for the root volume, and with this command, we've disabled indexing on that boot volume. And now we have something that we can turn into Chef. This is an execute block. We wrap that command in the execute block, we disable Spotlight, which was formerly step 14, as you saw before, and now we can create an image. And we have lots of these images we need to create, so it's rinse or repeat. Configuring remote management with the kickstart command. Disable screensaver with defaults. Disable time machine with tmutil. Don't forget to activate remote management with kickstart. Kill Bluetooth daemon. disable automatic software updates, enable remote login, disable sleep, right? Boom, we're state managed. So why go any further?
So while the code you just saw does work and works for our imaging purposes, it fell short for us in a few really important ways. For starters, a bunch of recipes wrapped up in execute blocks is not the most reusable code in the world, right? But beyond that, there are 3 characteristics of our infrastructure code that we really, really wanted when we decided to go past this initial iteration of the project. So I'm going to talk a little bit about some of the advantages we got by creating a higher level abstraction for interacting with macOS. The first abstraction I want to talk about is an elegant language. So one of the things we wanted most was an elegant way to write what we simply wanted to express as code and express our intentions without the unnecessary details of how that end goal is achieved. Let me show you a code example that describes what I mean. This is something from a pre-Mac OS Cookbook that we had implemented to apply a Bluetooth configuration to our Mac OS nodes. In the top portion, we have 2 declarative statements. One statement about the configuration file we'd like to change, and another declaring about how we want to change it. And in the lower half, we have this mechanism, the each do, a loop to go over these settings to execute a block to apply each of those settings. The lower half contains mostly just implementation details about how these settings get applied, but doesn't convey any useful information about the desired state of the system. So we decided to create a resource for defaults that would wrap up that implementation. So by creating a custom resource that integrates with the defaults command, we make the implementation details the responsibility of the custom resource. Well, here back in the recipe, all we have left are those declarative statements about the desired system state. Not only is this just nice and clean, our defaults resource actually fixed a pretty big bug in our old implementation. If I go back, the string interpolation down at the bottom where it says commands default right, that string interpolation is just going to take a 0 from the integer and false, a Boolean, and just write them as strings to this plist, which is totally not what we want. macOS will just ignore those settings. So by creating a defaults resource and testing it thoroughly, we find these kinds of bugs and we wrap up that domain knowledge and that implementation into the resource so you don't have to worry about it when you want to use the defaults recipe or resource yourself. So that's what we mean by elegant language.
Thanks, Jacob. So another thing that was super important to us that takes elegant language into it uses elegant language, but it's a little bit further than that. It takes it further. It was important that we wrote a domain-driven API. It was an API that was driven by our practice knowledge of macOS. But I'm going to go a little bit further into what I mean by that. So here we have the previous Spotlight management block. But to really understand it, it requires macOS domain knowledge about the mdutil command. You need to be aware of its switches, of indexing state, of what its output is, and the accepted arguments. And so we're going to do change here by extracting the implementation details of how we manage that into a resource that will expose an API that's much better suited to convey our intentions. So here's what our new resource block for managing Spotlight looks like. This new implementation reduces the domain knowledge needed. If you think back to the defaults resource that Jacob showed you earlier, that is elegant. It's beautiful. But it's not domain-driven because you still need to understand the key value pairs for that defaults resource. What the Spotlight resource does is it's declarative. It shows us that we want to manage Spotlight. And if we had a domain-driven API for Bluetooth, we'd have a Bluetooth resource that would have some properties that would indicate what we want to change about Bluetooth, not just the plist. So our resources implement our own defaults resource to make more declarative APIs. We don't want you to have to worry about those implementation details. So that's what we mean by domain-driven API.
So we knew that if you're going to write a cookbook that had valuable custom resources that we could use and share with others, that it would need to be extremely well tested. Lots of our own internal cookbooks already rely on these, so it's extremely important to us that we can trust it when we make changes or we pull in changes from the public on GitHub. So let's talk about testing. We use a familiar testing paradigm to some of you, Kitchen CI with Vagrant as the provider and Inspec as the verifier. But this paradigm posed some challenges for us. I'm going to talk a little bit about what we had with Kitchen CI.
If you've tested macOS before using VMs, you know that macOS instances are some of the most expensive to use. They're huge in size, sometimes getting to be 8 gigabytes, and boot times are super long. Other operating systems, Ubuntu and Docker, for example, that takes 30 seconds spin up to spin down, but macOS can push 5 minutes sometimes just for kitchen test. And that's with an empty run list. So it was super expensive. We just didn't have that time if we wanted to create really, these beautiful domain-driven APIs that I was talking about earlier.
So let's talk a little bit about the resource collection with ChefSpec and how it can rapidly decrease the time to get feedback about the code that you write with Mac OS Cookbook. As it turns out, Chef has a great unit testing framework extending the RSpec behavior framework, and it can drive really great design of your recipes when you subscribe to test-driven development. It's a great methodology. If you don't use it, I would highly recommend investing some time in it. Because with ChefSpec, we've had amazing success with testing our recipes internally and with Mac OS Cookbook. ChefSpec has become especially critical for our recipes that involve conditional logic based on attribute conditions and other parts and other node attributes. In this example of a basic resource collection for my recipe, we can tell ChefSpec that it's supposed to expect that these specific 4 resources would exist, for example, rather than some other given resource that we don't want in there. And for testing recipes and execute blocks, this feedback cycle was really good. It allowed us to predict how the chef run was going to go from that context. So ChefSpec is fast, right? You don't need to spin up an instance. It happens within seconds. But is it enough testing for us? We found that ChefSpec was really difficult to tailor when we were building our custom resources, specifically the custom resources that integrated directly with macOS and didn't just call other chef resources. When you have logic under the hood that relies on system state that's not in the context of a chef run, we couldn't really find a good way to make ChefSpec work for us. You can't really tell it to expect a specific API for like an external gem that we install to manage Xcode, or if we're parsing command line output from some macOS utility correctly. It only really works to use ChefSpec if you're testing your custom resource and it contains other chef resources that you can expect in there.
Yeah, like Jacob said, ChefSpec didn't make sense for testing things like parsing command line output or an external gem API. We needed to be able to test our resource logic outside the context of a chef run. We need to run unit tests that weren't part of ChefSpec, which is just tests the resource collection. It can test attribute variation, but it can't test really low-level resource logic and library files. So we needed a different design for these custom resources. Another thing is that the custom resource documentation that you see with some of Chef's DSL doesn't really allow for testing, unit testing. And we knew that we needed that. So they're used to extend Chef functionality, and they can be anything from a Ruby class or a Ruby module. So here's an example of an RSpec test that describes context in which we have a bunch of symbols to exclude while making sure we keep numbers. This method is used in one of our resources, machine name. If you don't already know, macOS will automatically convert any non-compatible host names in system preferences in the sharing option. So if you use a host name in there with periods, it's actually going to remove those automatically. So we needed to recreate that algorithm. But the programmatic execution using SCUtil, or system configuration utility, it's actually going to give us an exit code of 1, and that's going to kill our chef run if we try to give it an incorrect host name. So we needed to unit test this method to make sure that we could get those host names properly formatted before we actually put it into the chef run. Pure RSpec can seem a little daunting, but it provides much faster feedback around the design of these resources versus Kitchen or ChefSpec. And it can test business logic that ChefSpec isn't able to cover. So this example is just one of many that we use in testing that machine name resource. And the best part about this was that it pushed us to not only become better Chef developers, it pushed us to become better Ruby developers, which was really just a great end result.
So that about covers it for testing right now. I'm just going to wrap up by discussing a few more things that we have in mind going forward with our cookbook. We really want to expand the resource library to reduce the amount of domain knowledge you need as an administrator to manage macOS with our cookbook. Things like disk management, including the new APFS containers that Apple released last year, there's still not a whole lot of management techniques that we have for those, and we know it's a critical part of managing systems in the wild. We'd also love to look into managing file vault and disk encryption and Active Directory binding, because we know that's critical for desktop use cases in the enterprise as well.
Another thing, it's one of our loftier goals, but we want to achieve out-of-box management for macOS. I know we all love clicking through the welcome screen and all the dialogues, and do you want to submit feedback to developers and all that, but we would love to automate this process if given the option. We want to be able to give this management to all of your macOS endpoints, your workstations, your build nodes, your test nodes, all of that. And we think we can do that with all of these really awesome custom resources.
And then finally, compliance with Inspec is coming to the forefront. Compliance in general is coming to the forefront for many teams, including ourselves. And currently our Inspec tests are embedded in controls inside of the macOS Cookbook, so they're not easily usable for compliance scanning. It's way simpler just to rely on an Inspec profile that's referenced directly from GitHub that has controls in there that you can pick and choose for your fleet. So we'll soon be releasing a standalone Inspec profile to help ourselves as well as anyone who wants to use it in the community to help manage the compliance state for your macOS nodes.
That's it for us. Thanks, everybody.
Are there any questions we can answer? Yeah.
So Chef 14 actually contains some of the things that you have in the cookbook.
Yeah.
Is it going to conflict, or does that actually still work?
The question was, Chef 14 has some new support for macOS. Like, we know the Mac OS X user defaults resource is now built into Chef 14, so is any of our code going to conflict with that Chef 14? We've looked at a lot of those resources, and while we've been developing our cookbook really, really fast, we do think that a lot of our implementations cover more ground than some of those. I think that Chef hasn't probably put enough energy into macOS, and understandably so. But that's why this cookbook is important to us, because we've been doing this for a really long time. And so, we may see some of those implementations get into Chef Core, but specifically, we don't think that there's going to be any conflicts. I mean, it's up to the user whether or not they want to choose to use those built-in resources or ours. But they'll find that ours are, maybe item-potent in places that Chef's might not be. Ours might be better unit tested than Chef's. So it's really up to the user whether you want to pick.
But in short, they won't literally conflict. We've made sure they're namespaced properly. Yeah, generally the Chef resources have like Mac OS or specific user defaults. There are a few features that we cover, but we made sure not to use the exact same name, so you'd run into that issue.
Yep. Anything else? Cool.
Great. Thanks, everyone.
You got a question?
Go ahead.
Yeah,
Sure.
So you're talking about how you're using Kitchen CI
Yeah.
to build really dev builds of Mac OS going into Vagrant, and then so you're using the team server?
VSTS.
Yeah,
Yep.
VSTS. So is there a specific kitchen driver for that?
So the question was if there's a specific kitchen driver for VSTS. And no, we actually just use the Vagrant driver to build macOS images on the box that we test on. We use our boxes and we use them as VSTS build agents, but they actually have the hypervisor installed natively on the box, and then they pick up jobs from VSTS.
Yeah. So
but it's not a native VSTS integration, it's just something we made. Yeah,
the build definition just contains the commands and has some built-in Chef extension support, but it basically just runs a kitchen test, and then it's sort of like the VSTS build definitions are essentially like Jenkins jobs, and they can be expressed in like YAML too, so it's basically the same thing.
Yeah, if kitchen test wasn't already so easy to do CI with, it'd probably been a little harder, but we just had it execute kitchen test.
Yep, thanks. Cool. Awesome, thanks for everybody.
Oh, go ahead.
Oh yeah, Mike.
Apple seems to be pushing more and more to MDM.
Yeah.
What are your thoughts, and how are you prepared?
So one of the reasons that we saw this kind of coming, right? Apple has deprecated imaging for some time. Oh, sorry, the question was Apple's moving towards MDM. How do you guys want to handle that with imaging? And we've understood for a little while that deprecation means that we're probably not going to be able to image forever. The rest of the wider Office org definitely needs to pivot off of that. And that's one of the reasons that we wanted Chef to be something that we started working on last year, is that we have those resources for the nodes that are still managed by imaging, that we wanted to be able to take our Chef code that builds the image and just say to everyone, hey, this code that you're familiar with that already makes your image, we're just going to apply it to a live node. There's a couple things with StartOS install that we're looking to bootstrap and have the Chef client be just bootstrapped to our server once you run StartOS install. And I think there's currently a bug with 10.13.4 that's preventing that from working for us. We have something out with Apple, but I think as soon as we get that fixed, we'll be pretty close to making all of our nodes just directly start up using the OS installer and use Apple's approved method of imaging.
Yeah, Microsoft hasn't quite figured out how they want to manage Macs, and we think that we're doing that the best way right now. We're also kind of like in an isolated silo in our organization, but we're not really sure on certain aspects. We really like manipulating the preferences like right at the OS level and things like that. But it's possible that down the line we'll need to implement more Apple approved MDM solutions. But we kind of want to do it as pure as possible, if that makes sense. Yeah.
And then profiles, are you using them or moving towards them?
Yeah, I mean we don't have any plans yet, but we're probably going to need to, especially from others in the community and their experience and success with that. So still open to options. Yeah. Yeah.
A coworker of mine is looking into using something called Jamf. Are you familiar with Jamf at all?
Yeah.
Is this like a replacement for Jamf, or is the...
I mean, my personal opinion, yeah, I want to take it out. I want to take out Jamf. Like, you take Chef in the cookbook all day, baby.
Yeah, that's basically what we mean by out-of-box management. We used to use Jamf a little bit in the labs to manage our machines, but the value we were getting out of it versus the license costs was just really not there. And being in a dev environment means that you want to implement a lot of really custom things, and Jamf was not able to implement those for us anymore.
Not very fair to compare though, because it's actually moving away from a lot of other.
Oh, yeah, I mean, yeah, there's definitely a lot of tool sets we're not there yet. We would love to be able to say that we have a functionality that gets anywhere close to Jamf, but for us, it's definitely a matter of writing our own code base to do that, and not relying on that subscription and just having our cookbook be able to manage our nodes for us.
Someone out there compare what you're doing.
They're probably not comparable at this point.
Yeah.
Yeah, and there's a lot of people that use Jamf and use Chef. Tons of them. Like, it's very common.
Yep.
But we, like in our org, we didn't have the budget to afford Jamf, like just in our little org. And so we had to come up with something that was, affordable. And so, yeah, not that they're comparable, but maybe they will be someday. Yeah. Cool. Thanks.
Great. Thanks, everyone.
right. Looks like we're good to go. All right. So thank you everyone for coming to this session. We're going to be talking about a couple different things that we're strategically working on with Chef. Some of the future states of where Chef and Splunk are going to go with, and as well as some current integrations and a little bit of kudos to the community for contributing to the projects around it. Our legal department makes me put this up because there's some forward-looking statements in this presentation, so stuff that may or may not become a product, may or may not become a part of an open source project, so just fair warning. How many of you guys here today are Splunk customers? Wow, awesome. So I won't even have to spend too much time on this. As you guys know, Splunk is a machine data platform. We ingest all types of data. Specifically in automation, we're really focusing on helping you guys get better security insights, operational insights, and also get better business insights when you're actually deploying your application and actually validating things are actually being deployed correctly. As you know, we try to meet every expectation of the customers, so we're in all different types of verticals. This year, we just went into business analytics and IoT. As you know, data is a very hard thing to look at, and we try to make it easier for customers to actually analyze what they're ingesting and to get value out of it. And as you guys have heard, if you've had a sales rep tell you this, we make machine data accessible, usable, and valuable for everyone. The ideal is we want to make sure that as a community project, we provide value to you guys as well as integrating with solutions that Chef is offering around the commercial space as well as the open source space. Like I was saying, Splunk ingests all types of data points. As part of the strategy of working with Chef, we're really focused on hitting every type of vertical so that as you're justifying your automation strategies with your business, you can actually show them that your data is valuable to the whole organization. And because of that, we're trying to eliminate the complexity of IT. The reason why you're here today, you want to learn about automation, but we want to show you the data-driven approach so you can actually be smarter when you're deploying stuff. And of course, when you don't have data, you have lack of visibility. So when you're troubleshooting issues, when you're hand configuring something, you don't have any reference or a point of reference to blame anyone or even to tell anyone that there's something wrong. So this is why data is really important. And we want to have a consistent data stream of specific insights into what we're doing. So from an automation perspective, it's all about getting data insights to how we're automating, how we're deploying our applications, and then figuring out the monitoring perspective of it. So let's talk a little bit about Splunk and Chef this year. As you guys know, we've had a couple different integrations that haven't really been maintained, but that's partly because we want to basically find a better solution when we talk with the overall community so that we can help the open source community as well as the commercial user. And what that's going to really entail is around the 3 product sets that we're going to be integrating with this year, hopefully by our conference. And what it's basically going to include is Chef Automate, Inspect, and Habitat. And the reason why we picked these 3 different applications or these platforms is because we want to basically focus on the things that are important to you guys as a whole. We want to make sure that when you're looking at deploying with Chef Automate or even open source Chef, that you know how things are being deployed, how long they've been taking, and if there's any abnormal behavior associated with it. Inspect, we're trying to take Chef into a new realm of security. How many guys are doing DevSecOps opportunities right now within your own, couple. We want to help you guys see the value in actually bringing in the automation data to build KSIs so you can see what your posture looks like and if you have vulnerabilities in your network. And then, of course, with Habitat, we put a lot of development time and effort into OpenShift, Kubernetes, Docker. We want to extend that by automating it within the framework that you guys are working with currently today. And as you guys probably saw with the Twitter responses from our marketing department, kind of have like a cooking theme. But I really just want to highlight some of the things that we're really focused on when we look at these integrations. So we're going to be focusing on the products, how you are developing software, how you're deploying software. You're looking at how you're actually testing your cookbook. So we want to see how it looks over a period of time and capturing metrics based on that. We want to look at the operational value. So how is your Chef environment operating, and is it affecting how you're releasing? And then ultimately, how do we actually put security in the mix so that you get that full end-to-end view? And because of that, we want to help you deploy applications better by linking all these together. So to get a little bit more into security, one of the things this year we're focusing on how do we actually help customers see the value in Splunking their software delivery life cycle with a focus on automation and also what we call remediation. So a lot of integrations you're going to see this year really kind of highlighting the ideal that once we get the data into Splunk, we're going to make it valuable so that if something happens in your environment, we can hook into Chef Automate and maybe even remediate some issues that you may be having with a specific service and using those cookbooks to automate that orchestration. And the way we're going to do this is actually a two-step process. I don't know if you guys are familiar, we actually have a new product line called Essentials. These are really focused on use case driven, basically products and solutions that we built in the Splunk. These are free add-ons and free integrations. And we're going to basically focus a lot of the chef recipes that we're building and provide use case examples on how to implement them. So some really cool stuff coming up. As you guys know, we have a chef community cookbook. How many of you guys contribute to it today? Okay, perfect. So I just want to give kudos to the people that I've highlighted on here. Roy is actually the one who works with me, but he actually is one of the original developers with the cookbook. He did an awesome job, and as well as the others have done it, so I'm just giving kudos to the community, and hopefully that you guys will join the community and actually add more to it as well. But I also want to come here to talk about how do you guys get started working with the cookbook. So how many of you guys actually know about the cookbook that we have on the Chef marketplace, or do you currently use it today? Okay, only a few. So, I know a lot of you guys are automation engineers, so I'm not going to go too deep into this, but go to the GitHub page, clone the repo, create a branch, make your feature requests, apply your changes, put your enhancements, commit on your changes. Please make sure you put some notes in it. It's really hard to validate what was changed just by looking at specific things. Push your changes, test it using the Travis CI that's already baked into the repo, and then submit your pull requests. And supporting the newer versions of Splunk, as well as building in some security use cases as well, so you can automate how Splunk can be deployed in your environment. And as you guys know, if you're already developing cookbooks, Chef has a development kit. I was going to show you guys a demo of how we're doing deployments with Kitchen. Unfortunately, but I wanted to give you guys a little bit of insight. When we talk about doing development with the Chef cookbook, how these specific things can relate and help you actually build a better Splunk environment, and as well as using Kitchen to help test and deploy based on that. So how many guys are using Kitchen right now? Okay, perfect. So you're probably familiar with how you can use it for deployments, use it in a Vagrant environment. Really important when you think about the power of being able to take configurations that are default and putting other enhancement and changes and being able to push. You can actually take a look at how things are going to work for other members and getting feedback based on that. As you guys know, there's a ton of use cases with the cookbooks. You can actually deploy a standalone search head. You can do index clustering, multi-site clustering. We also are going to be doing additional pull requests around syslog, inputs, heavy forwarders, universal forwarders, and actually the deployment server as well. So some really cool things that we're going to be baking into our Essentials framework so you guys can see visually via step-by-step process how to deploy it, as well as getting the value of actually being able to commit to it as well. And with that being said, thank you guys for coming out. I just wanted to say, overall, we want to make sure this is a great experience, and thank you for coming to the session. And I'm opening up for questions if anyone has any, actually. So, sure. So we have 6 currently right now. So the cookbook, there's currently 6 right now. So, yep. Good. Yeah, so we're actually going to be working with Chef Automate team to actually build extensible reporting out of the platform. So we're going to be looking at operational value, how the Chef ecosystem's running, how many hosts are actually being deployed using Chef 0. Oh, yeah. Oh, sorry.